Okay, this is the first part of the notes for section 6.1, which is inverse circular functions. So before we just launch into everything with the trig part of it, I want to make sure that we review inverses first of all. So if you remember back to algebra, algebra 2, an inverse is when you switch x and y. So in order for something to be a function, remember it passes the vertical line test. Now, all functions have inverses, but the function is only considered a one-to-one function if the inverse of the function is also a function. So a couple of quick reminders. Let's take, for example, and that was a terrible drawing. Okay, let's take, for example, the good old quadratic. So that's the quadratic parent function. Pretend that this is perfect. This is not the easiest thing to draw with. If you remember, an inverse is reflected across the y equals x line. So it's reflected across this diagonal. And if I were to reflect the linear parent function or the quadratic parent function across that line, it would look like this, right? And it would not be a function. So we have to restrict the domain. So if you think we restrict the domain and we drop off the bottom part in order to make it a function. But just as it is not a one-to-one function. So that's what the horizontal line test is all about. So the vertical line test for functions and the horizontal line test checks for one-to-one functions. And that means that the function, the original is a function and its inverse is also a function. So you can see, I guess we've got the definition here for inverse function. Let me clear all my stuff off here. Or not. I guess I can do that. There I can clear all my drops. And the inverse function is defined like this. So a couple of things. The notation for an inverse is f to the -1. Do not confuse that with a negative exponent. It is not. That -1 is purely notation. That is it. You don't do anything with it. It's not mathematical. This is notation, and that means this is the inverse. So the inverse has data points yx, and the original would have the data point xy. So the x's and y's are always switched, which also means that the domain of f is the range of the inverse of f. The domain of f, sorry, I'll put f of x, is the range of the inverse of f of x. And that means that the reverse is also true. The domain of the inverse is the range of f of x. So the domain and range switches when it's the inverse because x and y switch. So that's what makes something an inverse. So one of the things that happens in trig that causes a little bit of confusion and problems for people is the fact that we use reciprocals often, and we also use inverses. So I want to make sure that you understand that we're talking about inverses where you switch in x and y. So this f to the -1 of x is the inverse of f of x. It is not the reciprocal. It is not this 1 over f of x. Those are not the same thing. Just want to make sure that we're aware of that the inverse is switching x and y, whereas the reciprocal is taking whatever the function happens to be and flipping it over. So they are not the same thing, and we confuse them often. So just want to make sure we don't do that. Okay, so on your notes, you will have a summary of inverse functions. So let's just go through them real quick. In a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So number one is basically telling you passes vertical and horizontal line test. That's what number one is telling you. In order to be a one-to-one function, it has to pass both vertical and horizontal. If a function is one-to-one, then f has an inverse, f to the negative one. Now, all functions have an inverse, but the inverse isn't necessarily also a function, which means you can't use this notation if it's not a function, because that's function notation for inverse. Okay, the domain of f is in the range of f of 1, f to the negative 1, and the range of f is in the domain of f to negative 1. So that means, remember what I just said a minute ago, they're swapped, domain and range, domain and range. So when you flip x and y, they flip, domain and range flip. The graphs of f and f to the negative 1 are reflections of each other across the y equals x line. And to find the inverse for f of x, follow the steps. Replace f of x with y and interchange x and y. Solve for y and replace y with f to the negative 1 of x. So let's do one real quick, just not a trig problem, just to remind you how to do it. So let's say you have this. Y equals 2x squared plus 3. And we want to find the inverse. So I am literally switching the letters x and y. That is it. I don't move anything else. So it becomes, I don't know why I can't seem to change colors here. It is not letting me change colors. Why? Oh, I know why. Oh, sometimes I am so dense. Move that out of the way. Okay, here we go. Now I know where I'm writing. All right, so I am going to switch x and y. Let me erase this and then switch x and y. Okay, starting over. Y equals 2x squared plus 3. All right, now I'm literally switching the letters x and y. So x equals 2 y squared plus 3. And now I need to get the new y by itself. So I just follow simple steps of algebra to get rid of everything that is with the y. So I'm going to subtract 3 from both sides. That would give me x minus 3 equals 2y squared. Divide by 2. That gives me x minus 3 divided by 2 equals y squared. And then take the square root of both sides. And that would give me x minus 3 over 2 equals y. Now, in order to make it a function, I would have to use just 1. This is technically positive and negative when you take a square root, but just 1 would leave me a function. All right, that was just to remind you about how to do an inverse. Now, I want you, the next thing I'm gonna do is include a link to a short video on watching the inverse of the trig functions. And the reason that I'm not doing it myself is because it's a drawing. It's actually reflecting it across x equals y, and it makes more sense if you can see it happen, and I can't draw it, especially at this point with this kind of technology. So please watch that. It's very short. It's like 3 minutes long. If you'll watch that, I think it'll help some of the domain restrictions make sense, and then we'll do example 1. All right, so that's all for this video.